Hey chemistry students, it's Mr. Ferguson,
And Mr. Hunter.
and we're here to introduce a special group of solutions that we call acids and bases.
And our first objective is to list some properties of the acids and of the bases, to name and write formulas for some acids and bases, and explain the Arrhenius definition of acids and of bases.
Okay, so we're going to get started. Let's do it.
So some properties of acids, we've dealt with them a lot in class. If you were to taste an acid, in fact, we actually do taste acids on a regular basis. If you eat oranges, they have a kind of a sour taste to them.
Vinegar.
Vinegar,
Right.
yep. They cause predictable color changes with certain chemical indicators. For example, they might turn blue litmus paper red, which is a very common indicator for us. And if they react with certain metals forming H2 gas.
And we've done that reaction a number of times, like magnesium with
zinc,
hydrochloric
yep.
acid, zinc with hydrochloric acid, but they make hydrogen gas. All right, so let's move on and talk about naming of acids. Okay, so to review acid formulas and naming, the general formula for any acid, or for at least most acids, is going to be H, the element hydrogen, in an ionic compound with some anion, and we just put the generic letter A to represent the anion. So how an acid is named is based on what anion the hydrogen's partnered with. So if the anion ends in ide, chloride, fluoride, okay, the acid name is going to be hydro, then the stem of the anion name with an ic on the end. So for example, if we have hydrogen chloride, HCl, let me write that. So if we have HCl, that's going to be hydrochlor is the stem, ic, acid.
Yep.
Okay, then we have acids that end in ate, like hydrogen sulfate, which would be H2, and then SO4, since this sulfate ion has a -2 charge. That's going to be the stem of the anion with ic on the end. So this one's going to be sulfate is the anion, so it's sulfuric acid. And then the third one are ones that end in ite. So we could go with sulfite, H2SO3, hydrogen sulfite. That's going to be the stem paired with the suffix OUS. So this is going to be sulfurous acid. And there's some other ones as well, but these are the three probably most common ones.
Yep. Let's go look at some bases. So some properties of bases, whereas acids tasted sour, these taste bitter. We don't usually eat bases on a normal basis.
No, and you really shouldn't taste chemicals
No.
as a way to test them as a general rule, but there are some food substances that have a bitter taste associated with them that could be due to the presence of a base. There are also some other compounds that have a bitter taste too. So
Cyanide.
Just because it tastes bitter doesn't automatically mean it's a base.
Yeah, so the other property is they'll feel slippery if you touch them. That's what I've warned you in lab, was like if your hands feel soapy, go wash them because your hands are turning into soap. They cause predictable changes with chemical indicators. Example, red litmus paper turns blue. And they are often an active ingredient in cleaning products.
Yeah, lots of bases in cleaning products. They work really well at breaking up like organic materials that a lot of times are what makes up our stains, and so on. So let's talk about naming of bases now. So the good news is that when you name a base, you really don't have to learn a separate naming system like you did for acids. The general formula is B, which is a generic cation, paired with the anion OH, always hydroxide in these Arrhenius type bases anyway that we're talking about now. They're going to be named simply as any other ionic compound.
Yeah.
So if, for example, we have NH4OH, we would just name that. That is ammonium. Like I forgot how to write completely.
Well,
what did I do? Now I erased.
It's ammonium hydroxide. I'm pretty sure you guys can spell that.
Hydroxide. Okay, if it was CaOH2,
Be calcium hydroxide.
Calcium hydroxide. So the base doesn't have any different name than the acid does, except it might have an AQ after it because they're generally dissolved in water.
All right.
All right, let's move on.
So this is leading us to our first type of acid and base definition. It is known as the Arrhenius acid and base. It was Savanti Arrhenius in the late 1800s developed his first theory explaining properties of both acids and bases. And he simply stated that an Arrhenius acid is anything that produces H plus ions in solution. So HCl would produce, when it was aqueously dissolved, H plus ions in solution. So that would be his definition of an acid. And for a base, if he took sodium hydroxide and put that in an aqueous solution, he would expect to see OH ions, and that was his definition of a base. So that's how simple the Arrhenius is. We have two other types of acid and basic naming systems to go over
I think we're
later.
gonna cover those in the next lesson.
This
right?
is our very first.
So, it's an acid if it makes that ion when it dissolves. It's a base if it makes that ion when it's dissolved. Done. Arrhenius acids and bases.
That's all you have to recognize is know that make an H plus and an OH. Right. So our first PVQ, would you guess that soap is an acid or a base? Explain your reasoning.
Okay, and the second one, based on the Arrhenius definition, if you had this compound right here,
Hydrogen phosphate.
H3PO4, would it be an acid or a base? And then, as a follow-up question, if it's an acid or a base, well, it's one of them. Once you figure out what it is, give its correct name.
Yep. All right.
All right,
Have a good
how
night.
about it?